So I kind of got this last minute. I've been a bit flexible with the presentation. I'm trying to be a little bit fun, but let's see what we think. So Leo killed the teleport star. We all know video killed the radio star, except it didn't. The question here is how and what happens to both teleports and ground segment as Leo takes more and more of a portion of the market. And also, let's look at the data center story, especially from the big vertically integrated data centers, and see what that impact had there to try and learn some lessons. Little agenda slide, that's just so I know what I'm doing. First of all, who was I? Why are you listening to me? Why am I here? I was the COO at Thalia Limited. We were a independent network operator operating many bands on many geosynchronous satellites, starting as an a HughesVAR, an iDirect VNO, iDirect hub operator, teleport operator, and then at that point I kind of exited the business. We bought satellite hubs, we evaluated them kind of at some detail. We established a teleport, and we built businesses in Africa, Latin America, and the Middle East. Who am I now? Since stepping away from that business, I've become a consultant specializing in satellite, telecom, and ISPs. I do a lot of procurement of satellite and terrestrial solutions. I help with product marketing, sales for ISPs and hardware vendors. I do technical consulting on free and open source software and network hardware. I bundle a lot of support services for ISPs and telco providers. And I founded a startup that helps ISPs, both in the terrestrial world and the satellite world, improve their customer support, including everything from the proceduralization of what you do when somebody calls you, to high-level tools that use what we would call AI today, to go and interrogate networks remotely and try and find out what the problems are. So the first thing that came into my mind when I saw ground segment was, Jesus, what is ground segment? And what does that actually mean? So I went to our friend Wikipedia, always the useful resource, and it comes up with, there's basically like 4 portions to it. There's the Earth station, or the teleport. I'm going to use the word teleport because that's what I've always used. What is a teleport? It's a building that has power and network connectivity and some Earth station antennas. They could be little Earth station antennas, they could be big ones, doesn't really matter. The second part is a command and control, which could be TT&C for a satellite, but that's a little bit upscale for what I'm talking about. So let's talk about a platform, which is either a broadband hub or SCPC modems. Then you have client premises equipment. It's not technically part of ground segment, but I think it bears talking about because the modem is very important on your customer site. And then you have this other section, which is launch facilities. I'm not going to really talk about launch facilities because I think it's kind of out of my bailiwick anyway. So I think there's a space segment, there's a teleport, command and control. Oh, I should have been going through this. There you go. So here's my number one problem with the satellite industry. From the beginnings of commercial communication satellites, satellite has been an artisanal industry. It means that everything is done by hand. The same way somebody who makes really great salami makes it, makes wine, makes hats, cabinets, dresses. We've always looked at each problem and said, I can solve that problem, and I'll use these tools, which are different than those other tools that I used for another problem, to solve it. So commercial data especially price-driven commercial data, has been the Wild West. We saw this in especially the Iraq War, where everything and everybody was trying to attack a problem. Different satellite bands were being used, different satellites were being used. American military service was flowing over Russian satellites. It was landing in Germany on an iDirect hub owned by somebody in England. I mean, like, it was a total free-for-all. And the good thing about it being a total free-for-all is we got a lot of interesting solutions, but every single solution was bespoke in some way. This means lots of fragmentation. We talked a little bit earlier about security. Security is an obvious point when fragmentation does not help you, right? We also can talk about, in this case, the commercial hubs, the platforms. At one point, a very major vendor, I went to do a review because we were thinking about buying one of their hubs. And they told me they had 17 branches of their MNC software in current maintenance. 17 branches ranging from like 4 major revisions because it had been forked for one customer and forked for another customer and forked for another customer. I don't know how many people have a programming background, but that is not the way you maintain a code base that's under active maintenance because it takes immense resources to maintain it. So the same vendor, we inquired about some of their industry standards, things that we would think are no big deal in networking. They were also very poorly implemented, if at all. For example, you could get SNMP data out from one modem, but not from the other one because nobody had ever fixed the trap that it was calling. And that doesn't work when you're trying to branch out beyond the small footprint you're in. And if you think this isn't a joke, just try and go and buy an off-the-shelf OSS BSS application and plug it into your satellite platform. Because I don't think it's going to work. I got to be honest with you. And I've seen this in practice many times. So platforms and teleports are organic and often unique. Unicorn is supposed to be $1 billion business. Unfortunately, this isn't a $1 billion business necessarily. And this is especially true in the developing world. So this was supposed to be a developing world slot, and I've got a lot of experience in that part of the world. This is a joke. It's a yurt with a satellite dish. But the fact is that a lot of teleports in the developing world are served by less reliable infrastructure. So power, network. Those are the two important things, right? And even in relatively developed places, they're not that good a lot of the time. Many are small and informal. And some of these informal teleports are bespoke solutions for things like banking networks, where they knew that the infrastructure of the country wasn't up to snuff, so they would bring everything in-house into satellite. There are really, really complicated regulatory issues in these places. And it's not just because they want to have regulatory issues, it's also because there are so few people who can afford to rely on this that it's seen as a bit of a cash cow for the government, right? And, when we talk about the developing world, let's not forget about client terminals for people that are being served from outside that area. So military, foreign governments, these are not just domestic users. So let's think about where the industry is going. I think that the industry is moving from an artisanal phase to moving into a more industrialized phase. We've talked about standardization. We haven't really talked about the software side, which is okay. But LEO operators now are following the same path that Hughes and Viasat followed at one point in establishing a vertical integration throughout their business. Except they're taking it a step farther, and they're vertically integrating the space segment and the space resources as well. But certainly in the ground segment, they build their own router platforms. They might license in transmitters. Hughes actually builds their own transmitters for a lot of their applications. And as those bought-in items are used, when they hit an actuarial limit, then they will be replaced by internal processes if it's cheaper. The important thing to think about with this is they own everything and they know exactly what's going on with the network, and they can iterate time and time again. And that iteration allows them to improve their products. Starlink has now produced, I think, 6 different terminals, including their government-focused terminal, their business terminal, and 3 revisions of their consumer terminal. These are public releases that you could actually buy. And I think in 5 years, you'd be hard-pressed to find any other satellite platform that's released 5 different revisions of their product into the market. So they're able to iterate much faster because they have a much higher number of customers going in. Now, if we talk about the teleport side, A lot of people are excited about LEO teleports because there's a lot of them going in and people are making money off of them, which is great. But there might be a problem with that too. And this is part of the problem. What happened with data centers? Data centers were built to standards, but they were built by vendors who had very, very big profit margins. HP, Dell, IBM, all of them had very low margins on their consumer products, very high margins on their enterprise products. And as the data center use by companies like Facebook and Google and other big internet companies grew, they took all of those design questions and started going get them again and saying, are we doing the most efficient thing? Do we need to be spending this money? Now, this has happened. Facebook led a campaign called the Open Compute Project. The Open Compute Project went back to the question of, are the equipment racks the right size? And they actually changed the size of the equipment racks. They changed the way power is sent to the PCs. They changed every design, and then they sent it out and said, now who wants to build these for us? HP, IBM, and Dell all went, oh my God, what's going on? This happened in the networking side. This happened in the compute side. This happened in the physical side. This happened in the facilities management side, where all of these things were brought in-house. It's not unrealistic to think that that's happening in the satellite world now as well. So what happened is a couple of vendors have tried to build alternate ecosystems. Like HP's got what they call GreenLake. And HP GreenLake is an alternate ecosystem where you can have your cloud inside HP. They will build it for you and monitor it for you, run it for you. It's very popular for things like domestic clouds, like the UK has just launched one, but it's not getting the kind of money it used to get. So the reality of this is where there used to be many, many, many small vendors, consolidation has occurred, and there are very few sizable vendors with lots of people fighting for scraps. And I think that ground segment is going to commoditize as well. Starlink and Kuiper have built their own platform from the SoC up. Teleport installations are absolutely standard. As you saw earlier, like Starlink will deliver their teleports on the back of a truck. It gets trucked off and installed. So it's difficult to find a physical place to put it, but once they've identified the location, it's dead simple to install it. It's all built on software standards. It's reproducible at what is a relatively small cost for the operator. So Starlink is not going to worry if one of their teleports goes offline or is unavailable because they've got plenty, they've got redundancy. Now, what's important to think about with that is intersatellite link. So with the intersatellite link, they can shift their teleport usage at will, even almost infinitely from one side of the globe to the other if they time it right. This is actually in active use for their forthcoming Starshield project, which is for the US government, where they promise that only Starshield satellites will handle their data and it will always land back in the US. It doesn't work yet, but that's their goal. But it's not just about reliability and making promises to the customer. It's also a commercially driven thing. So if you're running a teleport and you've got your Starlink installation, or it could be Kuiper, it could be anybody really, and they can switch from you to someone else immediately, and it's $1 cheaper over there, they will do it. And I'm going to tell you that the contracts you're going to have are going to seem fair in the beginning, but their lawyers can beat your lawyers up. There's no question about that. They've got billions and billions and billions of dollars behind them. So this also could mean where they have more difficult areas to establish ground stations, Africa, the Middle East, the Far East, they'll just skip doing it altogether, which means less infrastructure in country and more infrastructure being served from out of country. The important part to think about here is the end customer, because the end customer is where all the demand starts from. And if we're talking about broadband customers, they don't care how they get their connectivity. They really don't. A megabit's a megabit. They care about price, then they care about performance, and then they care about reliability. There's a lot of specialty and niche customers. There's oil and gas, governmental, military. But the question I would ask is how many vendors and specialty niche use cases can that support? It seems like there's a problem coming. And as I said earlier, I'm afraid that not everybody's going to make it through that. I agree, by the way, that geo isn't going away. But geo for broadband, I think, is going away. Because what consumers actually get, both from LEO and geo, is usually a cookie cutter service which is almost adequate. I have Starlink in my office. I use it as my primary connection for about 3 months while I was waiting for a terrestrial connection to be installed. It works for browsing the web. It works for watching YouTube. It doesn't work for updating your computer sometimes. Much like your mobile phone when you go roaming, your phone says, oh, you have 5 gigs of data to use while you're here. And then 30 minutes later, it says you've hit 95% of your 5 gigs and you're like, oh, I haven't done anything. That's exactly the same thing that happens with Starlink, because they're counting the handoff between the satellites, they're counting drop packets, they're counting all sorts of stuff that actually isn't appearing on your PC. So usually also you get really, really poor customer service. Now, with geosatellite last resort, we all know who the vendors were and still are. Usually you get very poor technical service and very poor customer service. They were built on a bedrock of U.S. Stipends from the government for rural connectivity. With LEO, they're the new kid on the block, but it's still a cookie cutter service. So much that they're trying to get the U.S. government business by changing the specification of what the business requires, not by adapting what they can offer to the business. Or you get an expensive bespoke service which meets the exact needs of the customer. Oh, that was the wrong one. So, I mean, it sounds like doom and gloom. And I'm going to talk around this one a little bit because obviously I'm way quick on the presentation. But the question is, what do we do? Do we give up? Do we give up the geo completely? No, there's lots of places where geo is good. As Scott said, geo for reliable comms is the only option right now in remote areas. We've had a competition between geosatellite and GSM for a long time. That's going to continue. GSM is going to erode into some areas, but again, it cannot necessarily be a reliable service. Can our technologies offer us any advantage? One of the things that people often talk about is the efficiency of satellite waveforms, the efficiency of the connectivity. The problem here is that almost every GEO HTS beam is very poorly loaded at this point. The old saying from a satellite operator always says, I'm sold out, but if you want a transponder, let me know. So I think that technology can offer us an advantage, especially in multi-network operation, hybrid operation, and orchestration, but we're not there yet where those are. What about alliances and consolidation? I mean, you have satellite modem manufacturers and you have satellite dish manufacturers. Usually the two aren't really talking together. They might do a deal to make a sale together, but there's not a lot of deep integration there. And for that matter, what about consolidation? You know that there are at least 1 or 2 LEO networks where they're going to consider outside equipment. So people who make the modems and people who make the flat panel antennas and antenna receivers need to somehow come together to be able to compete with those vertically integrated businesses. It's tough. You can also talk about ground segment with an operator. We've seen Hughes and Viasat both invest into different operators when they're offering broadband platforms, mostly to guarantee the sale of their own equipment. It's not always the best solution because you don't always get the best people on those, but it does work. And then what about developing differentiated services within the existing broadband platforms? Now, this is an idea for people who sit in the middle, kind of like myself. I sit in a commercial middle with a lot of things. There are underloaded broadband platforms throughout the world, both in GEO and, let's be honest, in LEO. Can we then develop something inside those platforms that fills those niche markets? Or can we repurpose GEO into a way that it fills those niche markets? And then, let's ask a question. Will commercial customers pay more for a well-supported service that is well-run? I think the answer is yes, because otherwise we wouldn't have business mobiles and business broadband and business banking, for that matter. There has to be a place where we see a crossover that higher dollar value is attached to something that is intrinsically similar but has better support. And I think that the last thing is we need to start from a perspective of, does this need to be a custom solution? Some things do, some things don't. And when you have something that doesn't need to be a customized solution, you've got a lot better opportunity to go shopping for different things. My company's promise, always your partner, never your competitor. We're always here to help people try and find the right solution for them. And I'm probably way early, but that's what I've got. So if there's any questions, I'd be happy to answer.
Questions because he will raise a shout, the 48 there. But then I have started like, well, you're not part already K flat. Should anything about national recovery that? She really gets Jen friendly wars, use national wealth and international. All the children.
Now, there's two kind of UK clouds. One is there's a UK government cloud that's being operated by Amazon, and that's inside a special division of AWS. And there was also, maybe last week, a Scottish data center announced a UK-based cloud service that all data would be maintained in the UK. It would never leave the country. I mean, you can do some of this inside the existing cloud services as well. Like Amazon, you can determine what region you want to be in and that kind of thing. I think that was a sovereignty play that they made. And I think it was carried in the trades, especially because they're using HP GreenLake and HP put some money behind it. There are a number of data center operators who are UK only. And they all offer some sort of cloud-based service, but it's certainly not to the level that AWS or Google Compute or something like that is.
These only available
I don't think, I don't know the answer to that, but I think commercially you'd be silly to only have access from the UK. I think that the promise is that all compute resources are in the UK. Data will never go outside the UK. The GDPR, although we're not technically in the European Union, is still a very prickly problem. And there's an additional problem when you get into outer regions, especially California now has just passed some additional privacy laws. So knowing where your data is being kept is really important. And I think that's the rationale behind it. Whether it will be anywhere near price competitive with anything is your guess is as good as mine. But actually, if you look at the costs of something like AWS or Google Compute, for a smaller business, it's really quite expensive. No problem. Anyone else?
Any questions?
Wow.
So you made a comment, oh wow, this works really well. You made a comment that geo is not dead, but maybe not for broadband. So what else is there?
Well, consumer broadband's the problem, right? And the problem with consumer broadband on geo is latency. The second problem with consumer broadband on GEO is that the existing GEO satellites are too expensive in space. And I know this is supposed to be a ground segment presentation, but let's talk about the space segment for a minute. They're too expensive. They can't easily duplicate additional coverage over the same region. And so if they have a growth center that they don't expect, they're into a multi-year planning process to bring additional resources online. And this is why frequent launch and having a spacecraft that is more or less a factory assembled, mass-produced item is a good thing for LEO and even for MEO. The first thing that I saw when O3b came out, I wasn't excited about O3b's latency or anything like that. One of the first things they did was establish an assembly line for satellites. And I thought, finally, somebody gets it. Not just a spacecraft bus that gets highly customized, but something that is just like, that's what we make. That's what we send into orbit. And as time goes on, we upgrade it with additional capacity, additional resources, additional processing, additional features. And that's how you continually push the envelope of what's available. Now, the downside, of course, in LEO is you got a very limited lifespan. So if you're not SpaceX, I don't know how you afford to keep launching every day to 3 days to refresh your network. But I think that GEO, for dedicated connectivity, specific instances, reliable comms, I don't think that LEO's there. I don't think it's going to be there for some time. Even satellite handover isn't flawless now, right? Yep, absolutely. Cellular backhaul.
Little unnatural content.
Yeah, broadcast is an interesting one. Broadcast is interesting except for the fact that in most first world areas, broadcast is coming down in favor of direct streaming now.
Okay. So I think you think.
No, there is, but it's not going to be the cash cow forever. Yeah. Thank you very much. Thank you, everybody.